Hi, I am Atanu. In this tutorial video, you learn triangles, its properties and theorem. Here I cover definition of triangles and its components, type of triangles, perimeter and area of triangles with Heron's formula, angle sum properties of triangle, exterior angles properties of triangle, triangle inequality theorems, midpoint theorem, and also some important diagrams related to triangles. First, we learn the definition of the triangles and its component. So, what is triangle? In geometry, triangle is two-dimensional, three-sided polygons or simple closed curve. Also have three angles or corner and three vertices. Now take this example. This is a triangle, and AB, BC, and CA. These are the three sides. The line segments. And A, B, C are the vertices. Three vertices. And angle A, angle B, angle C, three corners or angles. Case of angle A, you can write as this angle is actually the interior angle. You can write as this angle is the exterior angle, or here you can write as angle ACD is exterior angle are the linear pair. So we can write as angle ACB plus angle ACD is equal to 180 degree. Now we learn types of triangles. This is the second point of discussion. Based on side, triangles are classified into three types. The first is scalene triangle. Three sides length are different, then we can say is the scalene triangle. And also we can represent this length of BC, since it is opposite to the angle A, so we can C. So for the scalene triangle, A not equal to B not equal to C. Isoscale triangle, and here these two sides are equal, and this base two angles also equal. It's angle B is equal to. Next is equilateral triangle. Here the three sides are equal and three angles also equal, and each angle is angle B, angle C is equal to 60 degree. This AB is equal to BC is equal to CA. Based on the angle of the triangle, first of these type triangles is acute angle triangle. When the three angles are less than 90 degree, it is the acute angle triangle. Then is obtuse angle triangle. Here is the example, and this angle is obtuse angle, means greater than 90 degree and less than 180 degree. Clear? This angle, and here means angle P greater than 90 degree and less than 180 degree, and here only one angle should be the obtuse angle. Next is right angle triangle. This is 90 degree. All hypotenuse. And this side is called the base. This is one leg, and this is called the height, and this is another leg. And if the sides are B, A and C from the Pythagoras theorem, we know that B square is equal to C square plus A square. So this relation we should remember. Hypotenuse square is equal to base square plus height square. Next we learn perimeter area of the triangle. First we learn the general formula. So what is perimeter? So this is one triangle A, B, C, and we have already know that we can write this side as A, B and C. So perimeter is actually the total length of this boundary. Okay, so sum of this side is actually the total length of boundary. So that is the perimeter of triangle. So we can write as of triangle is equal to sum of all sides. Here perimeter of triangle ABC is equal to A plus B plus C. Next we learn the area of the triangle. Before learn the formula of the area of the triangle, we should know what is altitude of a triangle. Let's take this example. This from vertex A, if we draw a vertical line on this base BC, this D point lie on BC, and this is 90 degree. So AD is called the altitude of the triangle. In short, we can say the height of the triangle. Now let's consider this BC base length is A, since it is opposite to vertex A. So we can write the area of the triangle is equal to half of base into height. Let's consider this height is H and base is A, so we can write as half into A into H for triangle ABC. It is not necessary that all the times altitude should be inside the triangle area. It could be outside of the triangle. For the obtuse triangle, let's consider ABC. One of this height is outside of this triangle. If the base is A, so area, okay. Now we learn the fourth point, area of the triangles with the Theorem's formula. When the height not given, we cannot find out the area of the triangle with the above formula. In that case, we have to apply the Theorem's formula. So what is the Theorem's formula? Let's draw one triangle. This is A, B and C, and the lengths are A, B and C. So first we find out the semi perimeter. S is equal to A plus B plus C divided by 2. So A, B, C are the length of the three sides. It is the semi perimeter, half of the perimeter. Next we can find out the area of angle is equal to root of s into s minus a, s minus b and s minus c. Next we learn fifth point, that is angle sum property of the triangle. What is this? It is the sum of three interior angles of the triangle is 180 degree. Let's draw one triangle first. This is one triangle ABC, and these are the three interior angle. Okay, they are the different. Okay, in this triangle ABC, three interior angles are angle A, angle B, angle C. What the angle sum property say? The sum of this three interior angle is 180 degree. How you can prove that? Let's consider the same triangle, then draw a horizontal line here BC. Let's consider this line as EF. So you can write as EF parallel to BC. How do you draw? We can write, since AF parallel to BC and AC transversal, so angle FAC is equal to angle C, or you can say this C angle is actually how much? Angle ACB. This angle equivalent to this angle, right? And also AE parallel to BC and AB transversal this angle means angle EAB is equal to angle B. Again this B is how much? ABC. So we can write angle FAC plus angle BAC plus angle EAB is equal to 180 degree. Look at this. This entire angle is how much? 180 degree. So FAC is equal to angle C, BAC is equal to angle A, and EAB B is from 1 and 2 is equal to 180 degree. 1 and 2. Next we learn exterior angle property of the triangle. What is this? Let's understand this theorem with this example. Here ABC is a triangle. Now extend BC up to D. So we get the exterior angle CD. What the exterior angle property say? This exterior angle equivalent to sum of opposite interior angle. So these are the opposite interior angle. Angle A, angle B. or angle CAB and angle ABC. So from this exterior angle property of the triangle theorem, we can write as exterior angle ACD is equal to sum of opposite interior angle, that is angle CAB plus angle ABC. Okay. Now we learn the proof. This is the theorem. How you can prove that? Let's consider one triangle ABC and BC extended to D. So this is the exterior angle. Now from the angle sum property, we know that angle A plus angle B plus angle C is equal to 180 degree. From so we can write angle ACB plus angle ACD is equal to 180 degree, the linear pair. From here we can write angle ACD is equal to 180 degree minus angle ACB. So 180 degree minus angle ACB is equal to angle C. From here equation 1 we can write as 180 degree is equal to angle A plus angle B plus angle C from 1, and here it is the 1. So from here we can write ACD is equal to angle A plus angle B, or angle CAB plus angle AB. Clear? Next we learn the 7th point, triangle inequality theorem. Before discussion this theorem, we should know another theorem, that is, in a triangle the angle opposite to the greater side is greater angle and the angle opposite to the smaller side is smaller angle. So what that mean? If we consider one triangle, so from this first statement, in a triangle the angle opposite to the greater side, so this is the greater side, so this angle, let's consider this triangle as ABC, and here the side B is greater, so we can say that angle B is greater angle. And since this is the smaller side, is equal to C, so we can say that the opposite to the AB, that is angle C, is the smaller angle. And the vice versa, in a triangle the length of the side opposite to the larger angle will be greater than the length of the side opposite to the smaller angle. What that mean? If we draw a triangle ABC and three sides are B, A and C, so this statement say that the length of the side opposite to the larger angle, so here it is the larger angle, so this side means A is greater than opposite to the smaller angle, so this is the smaller angle, and C is the opposite side, so A greater than C. We have to prove the first theorem, and here it is equivalent. The first theorem is angle opposite to the large side greater than angle opposite to the small side. For this, let's take one example. EFG is a triangle. Here FG is a large side and EF is the small side. So we have to prove that this angle E greater than angle G. How you can do that? For this, we have to construct one arc with the radius EF which cut the FG at H. So you can say that this EF and FH are the equal sides. So EFH is a isosceles triangle. Okay. So if this angle X, then also this angle also X, and this is total angle is E and this is angle G. So from the exterior angle theorem of the triangle, we can say that angle X greater than angle G, because sum of opposite interior angle, that is angle HEG plus angle G, from exterior angle of triangle. And here, since this X is part of total E, so angle E is greater than angle X. So from these two we can say that angle E is greater than angle G. Now we learn triangle inequalities theorem. What it say? In Euclidean geometry, this theorem describes the relation between the length of the three sides of a triangle. It states that sum of length of any two sides is greater than length of the third side. Let's understand this theorem with an example. This is a triangle ABC, which opposite sides are A, B and C length. As per this theorem, we can say that A greater than B plus C, or we can say B greater than A plus C, or we can say C greater than A plus B. These all three inequalities relations are true. To prove this, let's take one example of this triangle ABC, and then with a radius AC and the center C, we draw a circle and extend this BC which cut at D. So we can say that these two are the radius. So DCA is a isosceles triangle, and from this ABC, the length of the three sides are opposite to the angle A, this is A, and opposite to this angle C is C, and opposite to the angle B is angle side, the length is B. Since it is equivalent, so this length also B. Now here it is very much clear that this angle is angle in ABD triangle, angle A is greater than angle D. Okay, that side opposite to the larger angle is greater than sides opposite to the smaller angle. So we can say side BD greater than side AB. Okay, so BD is what? A plus B. greater than AB is what? C. Proof. Next we learn the midpoint theorem. In geometry, midpoint theorem states that. Next you learn midpoint theorem. So what is midpoint theorem? In geometry, midpoint theorem states that in a triangle, the line segment connecting the midpoints of the two sides of the triangles is parallel to the third side and half of its length. So let's understand this theorem with an example. Here ABC is a triangle and D and E are the midpoint of AB and AC. So from this theorem, if we connect D and E, we get the line segment DE. This DE parallel to BC and DE is equal to half of BC. Let's prove that. For this, extend DE up to F so that DE is equal to EF. Already this is equal, AD is equal to DB and this is also equal, and here we construct this side also equal to this side. AED and triangle CEF, AE is equal to CE given, ED is equal to EF, construct AED is equal to angle CEF, vertically opposite. Triangle AED congruent to triangle CEF by applying the HAH rule. So from this congruence triangle, angle DAE is equal to angle FCE, CPCT, and AD or DA is equal to FC, CPCT. So we can say that DD is equal to DA is equal to FC and angle DAE is equal to angle FCE, means these two angles are equal. FCE, these are the alternate interior angle. And AC transversal. So we can say that AD parallel to FC. So BC FD is a parallelogram. Because BD is equal to CF and BD parallel to CF, and so we can say that DF is equal to BC and DF is equal to 2DE is equal to BC. So DE is equal to half of BC. And since BCAFD is a parallelogram, we prove that. So DE parallel to BC. So midpoint theorem derivation proof here. Vice versa, if DE parallel to BC and DE half of BC, then you can say that D is the midpoint of AB and E is the midpoint of AC. So reverse statement also true. As per this list, now we draw some special figure related to the triangle as a bonus point. Okay, sum of exterior angle is 360 degree. So what are those exterior angle? This is one exterior angle. Extend this. These three are the exterior angle of triangle ABC. So we can say that angle 1 plus angle 2 plus angle 3 is equal to 360 degree. Next we learn the different construction point related to the triangle. So here ABC, so we can say that angle 1 plus angle 2 plus angle 3 is equal to 360 degree. Next we learn the different construction point related to the triangle. So here ABC is a given triangle and D is the midpoint. Since D is the midpoint, since D is the midpoint, so PD is equal to DC, and this is perpendicular bisector. Since D is the midpoint, so PD is equal to DC, and this is perpendicular bisector. And this line is angle bisector. So here is bisect the angle B. So this angle is equivalent to this angle. If it is 1, it is also 1. If this angle is x, then also it is x. And if we connect this D point with A vertex, we get the median. This is the median. Now we can remember this construction. Here ABC is a triangle and BD and DC are the angular bisector of the angle B and angle C. So this angle is this angle, and here angle BCD is equal to angle AD, angle ACD. If these two angular bisector if these two angular bisector intersect at D, then we can write as angle D is equal to 90 degree plus angle A by 2. Easily we can prove that by the angle sum property between this triangle ABC and angle DBC. Here G is the centroid of the triangle. What is centroid? It is the intersection point of the three median
So here it is the center. Here it is the centroid G. This AD, B, this AD, BE and CF are the three median. They intersect at the G.